Welcome, chemists. Today we are discussing a really important part of chemistry, which is separating techniques. It's just like sorting your wares into different compartments of your wardrobe. But this time around, we are sorting out mixtures into their individual constituents. I remain Gambari Aminat, also known as Tanima. Welcome to another session with me on Chemistry with Tanima. Are you ready? Let's get started. During our last session, we discussed elements, compounds, and mixtures, and I defined mixtures as a substance that contains two or more elements, or two or more compounds, or compounds and elements physically combined together. Since they are physically combined together, they can as well be separated by physical means. Separating techniques are those procedures that we employ to separate these mixtures into their constituents using physical means. Now we choose these separating techniques based on the physical properties of the individual constituents of these elements. We have discussed physical properties under the nature of matter, and examples of them are odor, size, color, solubility, boiling point, melting point, and so on and so forth. If you have not watched these videos, you are missing out. So I'll be dropping the links in the description box below, so do well to check them out as they are going to aid your knowledge in subsequent topics that we'll be checking out. So let's look at some types of separating techniques together. But before we do that, I want to quickly chip in some terms that we might be using in the course of this session that you might not be familiar with before. And they are just four: soluble, insoluble, solvent, and solute. I'll be taking it from the bottom. Solute is simply a solid that is added to a liquid. A solid that is added to a liquid. Solvent is the liquid that you add that solid into. Solvent is the liquid that you add the solid into. Now, when I say soluble, soluble means it can dissolve. When I say soluble solute, it simply means a solid that can dissolve in a liquid. When I say insoluble, it means it cannot dissolve. So when I say insoluble solute, it simply means a solid that cannot dissolve in a liquid. So let's check out some types of separating techniques together. So we'll be taking a very quick look at this separating technique one after the other. Remember that I said that a mixture is separated based on their physical properties. So these physical properties or the physical properties of the constituent would determine the type of separating technique we will use for that mixture. Number one, hand picking. Hand picking is the type of separating technique used to separate a solid mixture. When I say solid mixture, it means a mixture that contains two or more different kinds of solids. We separate them based on their color and their size. Let's go back to our mother's kitchen. When we have beans, what we do is we pick these beans. We separate the beans itself from the impurities based on the color and the size of these beans. This is a very good example of what hand picking is. So you are separating the mixture based on the color and the size of the mixture just by picking them and separating the ones you need from the ones you do not need. That is basically what hand picking is all about. Sieving requires the use of a sieve, and it is used to separate a mixture of solid mixture as well. But this time around, we are not separating them based on their color because a sieve cannot detect the color. We are separating them based on their size. How do we do this? We get a sieve with a mesh. The mesh is the base of the sieve. We get a sieve with a mesh of a particular size. Now, if you are separating a mixture A plus B, assume B is the smaller one, you get a mesh with the size that B can pass through. Then you pour the mixture into the sieve and you sieve the mixture. This would allow B to come down and A that is larger particle would still sit in the sieve. That's how to use sieving as a separating technique. So a very good example of a mixture that we can separate using sieving as a separating technique is a mixture of sand and stone particles. So all you need to do is to get a sieve with a mesh that the sand particles can pass through while the stones cannot, and you pour it inside and sieve. So the sand particles will come through and the stone particles will remain in the sieve. Another type of separating technique is filtration. Filtration is a separating technique used to separate insoluble solids from the liquid, and we do this with the use of filter. An example of the filter that we make use of is a filter paper. Filter paper is usually circular like this. Then all we need to do to make use of it is fold it into four, then open one side of it in a way that it looks like a cone like this. Then after you have opened it this way, you place it in a funnel. Then you pour the solution that you want to separate, or the mixture you want to separate, through the filter paper. What this does is it holds the insoluble solid and allows the liquid to pass through it. Now, the insoluble solid that remains in the filter paper is known as residue, while this liquid that passes through it is known as the filtrate. So this method is effective for separating mixtures that contains insoluble solid from the liquid. Another separating technique is evaporation. Evaporation is used to separate soluble solid from solvent. A very good example is salt solution. This process is carried out by heating the mixture and allowing the liquid portion with a lower vapor pressure to evaporate, leaving the solids behind. In chemistry, this is preferably done in a water bath to prevent overheating and decomposition. Decomposition is a process by which the solids start flashing out. Salt and water solution is a very good example of a mixture that can be separated using this method. The salt and water solution is heated, the water is evaporated, and the salt is left behind. Another separating technique is decantation. Decantation is the separating technique used to separate a solution that contains insoluble solids from the solvent. Now, how is this done? The mixture is allowed to settle and the insoluble solid sits at the bottom of the mixture. Then the upper clear layer of the liquid is now decanted off. A very good example of this is when you are washing rice at home. When you are washing your rice, you rinse the rice, then you leave it for a few seconds so that the rice can sit at the bottom of the bowl. Then the upper liquid layer is then poured out carefully in such a way that the rice does not fall along with it. So that is simply decantation. So the next separating technique we'll be looking at is centrifugation. Centrifugation is also a separation technique that is used to separate insoluble salts or insoluble solids from their solvent. But in this case, the solution or the mixture would have suspensions of solid particles. They are not clumped up together. So we use a machine known as centrifuge. So what does this centrifuge do? Centrifuge is a machine that you can use to spin test tubes containing suspensions at high speed, allowing the suspensions to settle down at the bottom of the test tube. Then the mixture can be easily decanted off. So the next separating technique we have to discuss is crystallization. Crystallization is used to separate soluble salt from its solvent. Soluble salt from its solvent. But remember that evaporation is also used to separate soluble salts from its solvent. So why do we need crystallization? Well, crystallization is used to separate soluble salts that can decompose on heating from their solvent. So how do we carry out this crystallization process? What we do is we heat up the sample of the mixture to allow it to concentrate, then we leave it to cool down. Afterwards, we add few crystals of the same salt. When I say crystal, yeah, I'm talking about the solid. We add few crystals of the same salt into the solution, then scratch the edge of the container with a stirring of glass rod to induce the crystal formation. When this crystal has been formed, all we need to do is to filter the solution to separate the solid from the liquid. So the entire crystallization process is just making sure that the solid itself from the solution, and you filter it and separate the solids from the solvent. The next separating technique we have to look at is fractional crystallization. Fractional crystallization is a separation technique that is used to separate solutes from a solvent at different temperatures. Now, the mixture we are talking about here is a mixture that contains more than one solute. And the key point to note here is that these solutes must have different solubilities at the same temperatures. They must have different solubilities at the same temperature. Now, when the crystallization process is carried out, when the solution is cooled to, let's say, temperature A, solute A is formed. But when it proceeds or when it gets cooled further to temperature B, let's say solute B is also formed. So when you cool the mixture to temperature A and you notice that solute A is formed, what you do is to filter out solute A from the solution, then you repeat the crystallization process for solute B until solute B is also formed, then you filter it out. So it is simply carrying out the crystallization process more than once to get different solutes from a solution, provided that the solutes have different solubilities at the same temperature. So this would be the end of this part on separation technique. In our next video, we will discuss the remaining types of separating techniques. And I also have a gift for you when you watch the next video till the end. So stay tuned, like this video, drop your comments for me, and check out the next video when it drops. Make sure you turn your post notification on so you don't miss out as well. See you in the next one. Bye.